Hi, my name is Sandesh Ramesh.
I'm Nathan Asimov, and this is episode 3 of the Cybercar build, where we install all the electronics.
In the previous 2 episodes, we welded the frame and made the metal body for the cart. So, if you haven't seen those episodes, I highly recommend checking them out.
The main goal of this build was really just to bring the cart to life, so we added all of these features and components, such as an integrated sound system, adaptive lighting, displays for side mirrors, and so much more.
Basically making the brain baby from the Cybertruck and the Batmobile and kind of just smushing those together.
That being said, let's get on with the video.
So we start with the fender lighting. Nothing really fancy here. We just got LEDs going around with diffuser channels, and that is all hooked up to the Arduino. So all we gotta do is hit upload.
Depo on the beat.
Ta-da! We have lights! So, we just installed all the electronic parts, and now it's on to wiring. Nathan, why do we love wiring?
We love wiring?
That's right, we don't, because it's stupid, it's dumb, we're in cramped positions, uncomfortable places, and it's mindless repetition. Crimp, strip, attach, repeat. Crimp, strip, attach, repeat.
Hey guys, it's currently 5:51 in the morning. We just went on a 12-hour marathon of basically polishing up all the wires in the front cabin, just shielding them, routing them around the cabin so that it looks nice and none of the wires are in your way when you sit in there.
Yep, we just had to make the front cabin look pretty, but now it's on to the back where we get to test those boards we just made, but not today. We're going home. We'll see you in a minute. Future us here. So, we did get a tad lazy and did not record the wiring in the back.
But after many cans of Monster, here we are.
All systems have been routed and shielded to the rear here, wired to the respective microcontrollers.
But first, a quick tour is in order.
So, starting from the outside of the cart, we've got a bright LED bar for the head and floodlights. Then, all fenders are equipped with underglow, along with the belly of the cart as well. In fact, every single strip has individual pixels we can control. But this utility will be further shown in the next video. Integrated in the fenders are HD micro cameras in substitute of side mirrors, providing a live 1920 by 1080 video feed. We also have an omnidirectional microphone on top, and of course we have turn signals along the sides. Finally, we have an incredibly bright SKW812 strip for the brake lights, along with a rear backup camera.
Starting off the cabin, we have an RFID scanner available for manual access in event of a Bluetooth failure. Along the left side are the drivetrain and 12-volt system shutoffs in case of an emergency. Below that, we have a 5-port USB charging hub connected to a wireless phone charger. It also doubles as a wired interface to the master computer. Glaringly obvious is a 10.3-inch Lenovo tablet, which will be used as the main interface for controls. The The butterfly-style steering wheel has a display which will be used for reading important numbers to the driver. On the wheel are the turn signal and horn buttons. On the right side, we have this small 3D print contains a fingerprint sensor along with an internal microphone and push-to-talk button to talk to users outside of the car. Here, we have a control box which turns on and off the different speaker systems along the car. Speaking of speakers, this seat has a pair of 2-inch speakers integrated right behind the rider's ears, while the cabin itself also holds a pair of 4-inch speakers along its roof. Finally, within the rear is a 10-inch subwoofer for extra bass. Lining the top of the cabin, there are a slew of controls for the door, hatch, lighting, and soft cutoff switches for the car. Here, we have a tri-screen display holding 3 separate 7-inch displays. Lastly, we can't forget the interior lighting, which came out fantastically using 4 separate WS2812B LED strips diffused in aluminum channels to give it that extra effect.
Alright, now on to the beast in the rear. We obviously have an LED bar up here with 2 actuators to open up the hatch, but besides that, we have a ton of electronics. So, if you're not into that whole nerdy explanation, feel free to skip down below to the part where we show it off. But, if you are interested, I will promise to keep it short. So this whole system is controlled by 4 microcontrollers and 3 SBCs, or single board computers. We have one Arduino Mega that controls all the exterior LED strips and the relay that turns on the speaker drivers, while the other Mega is mounted on the physical UI board. This custom circuit board routes all the physical buttons and switches along with all the status lights to an array of transistors for control. The board then branches out to the actuator driving units that simply take in the corresponding data from the switches to move the door and hatch actuators. Next, we have the Teensy 4.0, which takes in the pedal inputs to then send to the drivetrain for motion. Then we have the Arduino Leonardo, mounted on the sensor board, which reads data from temperature and humidity probes mounted on various points of the drivetrain. While also reading the voltage and current of the battery, it also controls the RFID and fingerprint sensors. Alright, so that's all the microcontrollers. Now on to the SBCs. We have 2 Raspberry Pi 4 B pluses with 4 gigabytes of RAM. One controls the brake light LED while displaying the backup camera feed, while the other displays the 2 side mirror feeds while controlling the interior LEDs and controlling a relay that turns on and off the headlights. Last but not least, we have the master computer, an Asus Tinker Edge T with a quad-core CPU giving audio data and sending commands to all the other controllers. So, as for power, after the battery goes through those safety switches at the front, it goes to this 12-volt converter, which transfers it to 12 volts, and then splits into 5 and 24-volt lines to power all the various electronics you see here. Whew, that was a lot, but it takes a lot to make something like this. So, with that being said, enough of the nerdy explanation. We proudly present part 3 of the Cybercart, the electronics. But not everything on the cart works just yet. We've still got to figure out the serial communication bus between the microcontrollers and the computers, get the displays actually showing the camera feed and the iPad useful data, and honestly, just do a ton of coding altogether.
Which is why we have our fourth and final episode coming up, where we just program all the systems to work together and make one cohesive piece.
That being said, if you want to see the video the second it comes out, all you've got to do is hit that subscribe button down below.
Thanks for tuning in, guys. Take care.